Have you ever made a choice and wondered, what if I had done the other thing? What if I told you that in another universe you did? And not just in your imagination, but in a real parallel world. This isn't science fiction. It's a mind-bending possibility born from the strange rules of quantum mechanics. Today we're diving deep into the concept of the quantum multiverse. So, how does this work? It all starts in the bizarre world of the very, very small, the subatomic realm. Imagine an electron. Before we measure it, quantum mechanics tells us it doesn't have a single definite position. Instead, it exists in a cloud of probabilities, a superposition of being in many places at once. It's like a spinning coin, simultaneously heads and tails until it lands. The act of observing or measuring the electron is what forces it to choose a single state, collapsing this wave of possibilities into one concrete reality. We see the coin land on heads. This is where the many worlds interpretation, proposed by physicist Hugh Everett III back in the 1950s, comes into play. Everett asked a revolutionary question. What if the wave of possibilities never collapses? What if, instead of choosing one outcome, the universe splits? In this view, every time a quantum measurement could have multiple outcomes, the entire universe branches into a set of parallel universes, one for each possible result. So in one universe, the coin lands on heads. In another, a perfect copy of our universe branches off at that exact moment. And in that reality, the coin lands on tails. Think about that for a second. This isn't just about coins. Every single quantum event, from the decay of a radioactive atom to the firing of a neuron in your brain, creates a split. When you stood at the crossroads and chose to turn left, another version of you, in another universe, turned right. There's a universe where you took that job you turned down. A universe where you said yes instead of no. A universe where you had cereal for breakfast instead of toast. The number of these parallel worlds is staggering, possibly infinite, each one just as real as our own. Each version of you in these other worlds believes their universe is the only one. They're all you, living out the consequences of every possible choice and every random quantum flicker. This concept might sound like it came straight from a comic book, and indeed pop culture loves the idea of multiverses, but it's a serious theoretical framework that some of the world's brightest physicists are exploring. Why? Because it elegantly solves some of the most puzzling paradoxes in quantum mechanics, like the measurement problem. Instead of a mysterious collapse that we can't explain, the many worlds interpretation suggests a continuous branching evolution of the cosmos. There are no paradoxes, just an ever-expanding tree of realities. Let's consider the famous thought experiment, Schrödinger's cat. You place a cat in a sealed box with a radioactive atom. If the atom decays, it triggers a mechanism that releases a poison, and the cat perishes. If it doesn't decay, the cat lives. Quantum mechanics says that until we open the box, the atom is in a superposition of both decayed and not decayed. According to the Copenhagen interpretation, the cat is therefore both alive and dead at the same time, until we look. It's a paradox that highlights the weirdness of quantum mechanics. But the many worlds interpretation offers a different, perhaps more intuitive answer. When the atom enters its superposition, the entire system, cat, box and all, splits. In one universe, the atom decays, and the cat is sadly no longer with us. In a parallel universe, the atom does not decay, and the cat is alive and well, probably wondering when it's going to be fed. There's no paradox of a zombie cat, because both outcomes happen just in separate branches of reality. We, as the observers, are also part of this system. When we open the box, we simply find ourselves in one of these branches, the one where the cat is alive, or the one where it's not. Another version of us, in another branch, has the opposite experience. So where are all these other universes? The theory suggests they are all around us, coexisting in the same physical space, but on different planes of reality. We can't see them or interact with them because once the universe splits, the different branches become decoherent. They can no longer influence each other. It's like tuning a radio. There are countless radio stations broadcasting at the same time, but you can only listen to the one your radio is tuned to. The other stations are still there, existing in parallel, you just can't perceive them. These parallel universes are tuned to a different quantum frequency, making them invisible and inaccessible to us. Now, I know what you're thinking. Is there any proof? This is the biggest challenge for the many worlds theory. Because we can't interact with these other universes, it's incredibly difficult, perhaps even impossible, to test the theory directly. It remains an interpretation, a philosophical and mathematical framework, rather than a falsifiable scientific theory in the traditional sense. Critics argue that a theory that can't be tested isn't really science. They also point to the sheer cosmic extravagance of it all. Does it really make sense for the entire universe to duplicate itself for every tiny quantum event? It seems to violate a principle called Occam's razor, which suggests the simplest explanation is usually the best one. However, proponents like physicist Sean Carroll argue that the many worlds interpretation is actually the simplest. The underlying equation of quantum mechanics, the Schrödinger equation, describes a smooth, continuous evolution of the quantum wave function. The Copenhagen interpretation adds an extra unexplained rule that the wave function suddenly and randomly collapses upon measurement. The many worlds theory doesn't need this extra rule. It just takes the Schrödinger equation at face value and follows its implications to their logical, albeit mind-boggling, conclusion. The theory itself is simple and elegant. It's the consequences that are vast and complex. Whether it's true or not, the quantum multiverse opens up a universe of fascinating possibilities. It changes our perspective on life, choice, and identity. If every outcome is realized, does that mean our choices don't matter? Not at all. Your choices still determine the path you experience in your branch of reality. You are the author of your own story within your own universe. The fact that other versions of you are writing different stories in parallel does not diminish the significance of your own journey. It also offers a strange kind of comfort. Every mistake you feel you've made, every missed opportunity you regret, there's a universe where you got it right. Somewhere in the multiverse, a version of you is living your dream life. And conversely, for every success you've had, another version of you failed, reminding us to be grateful for the path we're on. It's a humbling and profound perspective that connects us to a cosmic tapestry far grander than we ever imagined. The next time you look up at the night sky, remember you might not be looking at just one universe, but an infinite sea of them, all shimmering with the endless possibilities of existence. What do you think? Is the many worlds interpretation a brilliant solution to quantum paradoxes, or just fascinating science fiction? Let me know your thoughts in the comments below. It's a topic that truly stretches the limits of our imagination. Thank you so much for joining me on this journey through the quantum multiverse. If you enjoyed this deep dive and want to explore more of the universe's biggest mysteries, make sure to hit that like button and subscribe to the channel. Don't forget to ring the notification bell so you won't miss our next adventure into the cosmos. Thanks again for watching, and I'll see you in the next video. Have you ever felt like you're living in a game? That feeling of déjà vu, the strange coincidences, the moments that seem almost too perfectly scripted. What if I told you that feeling might be more than just a feeling? What if our entire reality, everything we see, touch, and experience, is actually a highly advanced computer simulation? And what if it's not the only one? Welcome to the mind-bending concept of the Simulation Multiverse. This isn't just an idea from science fiction movies anymore. It's a serious hypothesis discussed by leading physicists, philosophers, and technologists. The core idea is simple, yet profound. Our universe is a program. Just like you might run a game on your computer, a vastly superior intelligence beings we might call programmers could be running our reality. But it doesn't stop there. Think about how many different games or programs can run on a single computer at the same time. The Simulation Multiverse theory suggests that our universe is just one of countless simulations running concurrently. Each one could be a unique program, a separate instance of reality with its own set of physical laws, its own history, and its own inhabitants. Imagine an infinite cosmic server farm, with each server rack holding billions of universes, all humming along simultaneously. This idea actually stems from a logical argument. Let's break it down. First, assume that consciousness can be simulated. If our brains are just complex biological computers, there's no fundamental reason why an artificial intelligence couldn't replicate consciousness. Second, consider the trajectory of our own technology. Look at how far video games have come in just a few decades, from simple pixelated blocks to hyper-realistic virtual worlds. If we continue on this path, it seems almost inevitable that a future civilization, whether it's our descendants or another species entirely, will be able to create simulations of their ancestors, that's us, that are completely indistinguishable from reality. Now here's the kicker. If a civilization can create these ancestor simulations, they wouldn't just create one. They'd likely run thousands, millions, or even billions of them for research, for entertainment, for reasons we can't even fathom. So, if you do the math, the number of simulated realities would vastly outnumber the one single base reality. Statistically speaking, it becomes overwhelmingly more probable that we are living in one of those countless simulations rather than the one original, non-simulated universe. We are far more likely to be the NPCs in someone else's cosmic game than the players in the base reality. So if we are in a simulation, who or what is running it? Are they benevolent scientists studying the origins of life? Are they cosmic artists creating universes as a form of expression? Or are we part of a high-stakes game for entities beyond our comprehension? The programmers would exist in a higher dimension, a level of reality completely outside our own. To them, our laws of physics would just be lines of code. They could, in theory, pause, rewind, or even edit our reality. This leads to some fascinating and slightly unnerving thoughts. Are miracles, glitches in the matrix, or unexplained phenomena simply the programmers intervening? Maybe they're patching a bug, or just having a little fun with the code. What we perceive as the speed of light might just be the processing speed of the cosmic computer our universe is running on. The pixelation of our reality might be found at the smallest possible scale, the Planck length, which physicists describe as the fundamental limit of measurement. The multiverse aspect of this theory adds another layer of wonder. Each simulated universe could be a different run of the program with slightly altered parameters. What if there's a universe where the dinosaurs never went extinct? A universe where gravity works in reverse? A universe where you made a different choice this morning, leading to a completely different life? According to the Simulation Multiverse, all these possibilities could be playing out right now, in parallel programs running alongside our own. Each simulation could be a self-contained bubble, completely unaware of the others. We would have no way of directly contacting or observing these other universes, just as a character in one video game can't hop into another. Our only connection is the shared hardware and the programmers running the show from the outside. This concept also offers a potential explanation for the fine-tuning of our universe. Scientists have long been puzzled by the fact that the fundamental constants of physics, like the strength of gravity or the mass of an electron, are exquisitely balanced to allow for the existence of stars, planets, and life. If these values were even slightly different, the universe as we know it would be impossible. In a simulation multiverse, this fine-tuning makes perfect sense. The programmers could have run countless simulations, tweaking the parameters each time, until they found a set of settings that resulted in a stable, interesting universe capable of generating complexity and consciousness. Our universe isn't a miraculous accident, it's the result of cosmic trial and error. We're living in the Goldilocks version of the software, the one that worked. So, how could we ever prove this? Is there a test we can run from inside the simulation to see the code? Some physicists propose that we could look for evidence of the underlying grid of the simulation, perhaps in the distribution of cosmic rays or in subtle anomalies in the laws of physics. If the computer running our universe has finite resources, there might be computational shortcuts or rounding errors that we could detect with precise enough instruments. It's like looking for the pixels on a screen by zooming in as far as you can. But even if we found such evidence, what then? Would it change anything about our daily lives? The love we feel for our families, the beauty of a sunset, the joy of discovery. These experiences are real to us regardless of the ultimate nature of reality. Whether our world is made of atoms or bits of code, our consciousness and our choices within this framework still matter. The Simulation Multiverse is a powerful thought experiment that pushes the boundaries of science and philosophy. It challenges our most basic assumptions about what is real. It suggests that reality is layered and that we may be part of a much larger, more complex cosmic structure than we ever imagined. We might be living in just one story among an infinity of others, all playing out on the grandest stage imaginable. So next time you see a glitch in your day-to-day life, a strange coincidence that defies explanation, just smile. Maybe, just maybe, it's a sign that the programmers are watching. Thank you so much for joining me on this journey into the Simulation Multiverse. If you enjoyed this deep dive into the nature of reality, please hit that like button and consider subscribing for more content that explores the biggest questions in the cosmos. I'd love to hear your thoughts in the comments below. Do you think we're living in a simulation? See you in the next video.